Are we live? Yes, we are. All right, we are in lesson 6. Today, I should write down what our goal is. 1 second. All right, what are we doing today? Determine whether situations are characterized by exponential growth or by exponential decay with descriptions and graphs. Okay, and we're also going to learn how to write equations that represent exponential decay. All right, we've already learned how to write equations that represent exponential growth. So same idea, we're just getting smaller. All right, let's jump right in. So fractions and decimals. In the table, find as many patterns as you can. Use one or more pattern to help you complete the table. Be prepared to explain your reasoning. All right, so our fraction is 1/2. Our decimal is 0.5. Okay, our fraction is 1/4. Our decimal is 0.25. 1/8, 0.125, 1/16, etc. Okay, you guys find a pattern for that? All right, let me change colors. One thought is, sorry, each number is half of the previous number. Okay, and that would be in this row. So 1/4 is half of 1/2. 1/8 is half of 1/4. So really we're dividing by 2. And even here, okay, 0.5, if I divide that by 2, I get 0.25. And grab your calculator and double check that so you feel some ownership in your brain. So we're dividing by 2. That's one way to look at it. All right, you can write that down if you like. I'm going to erase it so I have some more room. Okay, that's not my favorite pattern, but it is a true pattern. All right, if you look at the non-zero digits, let's see. So just look at the 5. If we have 5 to the first power, it's right there. Right here we have 5 to the second power. Right there we have 5 to the third power. I do not know what 5 to the fourth power is. So I assume this one's going to be 0.625 because that is 5 to the fourth power. And if I take 0.125 and divide by 2, I get 0.0625. 1 second, this one is wrong. I forgot a 0. So that would be my non-zero digits. 0.0625. My handwriting a little bad right there. Oops, lost the 1 too. All right. And if I look, this is 2 to the first power. Looking at the denominator, it's 2 squared. The denominator is 2 cubed. Denominator is 2 to the fourth power. Denominator is 2 to the fifth power. And if I have 5 to the fifth power, I would have 0.03125. So I like that pattern. That was really neat. I hadn't ever thought of it before looking through this lesson last year, to be exact. But so looking at some patterns. One more. Let's erase and change colors again. Again, you can write that down, push pause, rewind, the great thing about a recorded lesson. You can hear me say it as many times as feels comfortable to you. All right. Now, 0.5 can be written as 5/10. Okay. 0.25 can be written as 25/100. 0.125 can be written as 125 over 1,000. All right. So the numerators are powers of 5. 5 over 10. And this would be 5 squared over 10 squared. This would be 5 cubed over 10 cubed. Really interesting, isn't it? 5 to the 4th power over 10 to the 4th power would give us that 0.0625, or 625 over 4 zeros. You know, when you have 10 to the 4th power, that gives you 4 zeros if you actually calculate it out. 5 to the 5th power over 10 to the 5th power. So that would be 5 zeros. And then 5 to the 5th power is 3125. So that's super interesting too, right? And still that denominator in the fraction is 2 to the 1st power, 2 squared, 2 cubed, 2 to the 4th power, and 2 to the 5th power. And honestly, the numerator is 2. That's 1 to the 1st power, 1 to the 2nd power, 1 to the 3rd power, 1 to the 4th power, and 1 to the 5th power. All right, let's move on. Okay, falling and falling. The value of some cell phones changes exponentially after initial release. Here are graphs showing the depreciation of 2 phones, 1, 2, and 3 years after they were released. Okay, which phone is more expensive to buy when it's first released? So our initial value for the first phone, phone A, is $1,000. The initial value for the second phone is $840. So phone A is most expensive. And I'm going to say initially because that's the word that we've been using. Okay, for the beginning, it's $1,000. How does the value of each phone change with every passing year? So we're trying to figure out, it decreases. That's going to be one thought that we have. Okay, that's not the most important thought, but it is one thought. I really want to know how much it decreases by. Okay, that's what we're really trying to figure out, is how it decreases. We can say that phone A, okay, they both decrease. Phone A is decreasing more rapidly than phone B. If we look at the 3rd year, I'm at a higher value than the 3rd year. So I will say that phone A decreases more rapidly. I'm not sure if that's proper English. More rapidly? Rapider? It's depreciating or decreasing. Another word for decreasing that would be a more financial word is depreciating. Right? Okay, now I'm going to wish I had that graph. Which one is falling in value more quickly? Explain or show how you know. I guess I already said it, but I didn't explain why. Here, looks like we're losing $400, and then we're losing $240. 600, that'd be 400. Yep. And then here we're losing 220, 320, 340, 144. 144. Okay. 840 minus 630. So we lost $210. 472.5. This is showing us that it's an exponential function too, because our differences aren't equal. And remember, I've said the differences are the subtraction and addition. Okay, this is definitely changing by a factor, which is multiplication. Okay, if it were changing by consistent subtraction, then it would not be exponential, it would be linear. But our subtraction is different every time, so it is exponential. What was this question? So I don't have to change my page. Which one is falling in value more quickly? Explain or show how you know. Okay, we can definitely say that phone A loses $400 in the first year. Okay, we don't know how much that is, but we can figure it out. If we're going from $1,000, we've done scale factor, to $600. How much did it change? Well, I'm going to do 600 over 1,000, and that gives me 6/10, which is 2/5. No, it isn't. I'm going from $1,000 to $600. 3/5. That's remaining. All right, let me rewrite this. That I didn't need to erase. So if we're doing $1,000 goes down to $600. 2/5 remains. So how much did we lose? Sorry. Doing great. 3/5 remains. I love math. I love fractions. 2/5 is what we lost. And I could get 2/5 by saying 400 over 1,000. All right. So 3/5 remains, 2/5 lost. So phone A is falling in value more quickly. So we lose $400 in the first year, which is 2/5 of the initial value. Okay, it's what I've said in words. I just didn't write it down yet. Let's see, we lose, look back at your graph. I wrote $240 the second year. And if I did 240 divide by, I'll write it over here. 240 over the previous value was 600. That is also 2/5. Lose 240, which is 2/5 of not the initial value, but the previous value. Right? Now let's change colors and talk phone B. And I'm out of space. All right, you guys can pause and rewind and write stuff down. I am going to get myself some space, okay? Please know, if you did not write that down yet, you can push rewind, pause, and write it down really quickly. So let's see, phone B, and up here we wrote it all down. Okay, we lose $210. Phone B loses $210. The initial value was 840, yep. $210 divided by 840. That's 1/4 of initial value, which is less than 2/5, if you didn't know. That's the first year. Second year, We're losing 157.5. So we'll take that 157.5 over the previous value, which was 630. And it should be the same. Oops. Which is 1/4. And it's not of initial value, it's of previous value. So the question asked, which one is falling in value more quickly? Explain or show how you know. Therefore, we know that phone A loses value more quickly because we're losing 2/5 of the previous value each year. So that is the one that is losing value more quickly. If the phones continue to depreciate by the same factor each year, what will the value of each phone be the 4 years after its initial release? So let's change colors again. This is year 3. If we wanted to do year 4, we're going to take the previous value, which is 216, and how much remains, which is 3/5. Because I want to know how much is remaining. And my value would be 129.60. Here we have 354.38, and we lose 1/4 each time, so 3/4 is remaining. So 354.38 times 3/4. 265.785, so let's just round that up to 79. So notice I did not use the amount we're losing each time. I used the amount that remains. Okay, this is lost value each year. So I multiplied by the value that remains. So if we lose 1/4, 3/4 remains because those add up to 1. If we lose 2/5, 3/5 remains because those add up to 1. All right, make sure I got that right. Yep, 129.60 and 265.79. Yay! See above. For each cell phone, write an equation that relates the value of the phone in dollars to the years since release. Use V for the value of phone A and W for the value of phone B. So we want V of T. Oh, it's an equation, not a function. So just V. Okay, what is our initial value? 1,000. And how much remains each time? 3/5 raised to the T. And then we have W equals, my initial value was 840. How much remains, which is 3/4 raised to the T. Okay, this one's a little bit more difficult. Okay, if you would like to get a bonus point, you may email me. Put some details in it, and if you could please title the email Lesson 4, Are You Ready? Or something. Okay, I'm having a hard time tracking what people are emailing me. All right, but it'll be +1 on your next quiz. And this we will try to do in class. I've got everything ready. We'll try. If we are in class, it can sometimes be a question. If you're watching this video in our pandemic, we're going to try this in class. If we are virtual for some reason, I may put together a Google Doc. Who knows? All right, that is it for today. Oh, but it is important. There is our lesson summary, which is oh so Wonderful, and a great way to study for an assessment.